As you probably already know from the title of the video, we will be talking about the Trilab Deltic 2 3D printer with the FlexPrint 2 extension. In this video, you will see a total of 3 printers. Only one of them was brand new and was borrowed directly from Trilab. The other two I had borrowed from private owners. No one is paying me for the review and no one has any influence on the final video. Just for the record, this video wasn't actually supposed to be released at all. I started working on the video in July 2021. Unfortunately, my life and work situation changed completely after that. The same goes for Trilab, where Trilab was acquired by Prusa Research. That's why we agreed with Trilab to cancel and not release the video. I got my hands on a third printer that behaved the same as the previous two. That's why I decided to finish the video. On June 13th, 2022, this video was released in an extended version in Czech language on my second YouTube channel. Now it's time for the English version. First, we take a look at the contents of the packaging of the new printer sent by Trilab. The package contained everything you need for a successful start with this printer. Spray with isopropyl alcohol to clean the build surface. Power cord, 24-volt power adapter, spatula for removing the prints, small cutting pliers, a bag of components to attach the FlexPrint 2 extension, 3D printed filament holder, black PLA filament from Filamentum, 3D printed torque wrench for changing the nozzle, Titan extruder from E3D with filament sensor, FlexPrint 2 extension, USB network card, Redmi 9N mobile phone which serves as a controller for the printer, and finally the print sheet with the PEI layer and my fingerprints. To start with, we will only need the following components. Setting up the printer was relatively simple. First, I had to remove all the red arrows. Then, to place the filament holder, install the Titan extruder, and plug in the filament sensor. I attach the PTFE tube to the extruder, attach the print head cables, and plug them into the printer. Now the printer was ready for the first start. All I had to do was connect the printer to a power supply and turn it on. Here you can see the old and the new version of the power supply for this 3D printer. The last thing we needed to do was to turn on the mobile phone. After turning it on, I was asked for the password, which I found in the manual after a bit of searching. The phone comes with the Delta Control application, which is used to control the printer via Bluetooth. Controlling the printer with the phone is more limited than with a computer, but we will look at it later. Before I show you the print quality and say something about the reliability of this 3D printer, you will definitely be interested in the price and what all you get with the printer. At the time of recording, the printer was available at the Trilab store. The Trilab store is no longer available. However, the printer can be purchased at prusa3d.com. The cheapest option is for $3,259. The most expensive option is for $3,803. Prices are without tax. It all depends on the accessories and the size of the printer. The printer is sold in two variants. Both variants have a build area diameter of 250 mm. The first variant has the ability to print up to 300 mm high, and the second variant up to 500 mm high. The versions I tested were all only up to 300 mm high. There is a large emergency stop button on the top of the printer. Precise movement is taken care of by the linear rails from THK's SRS series. Filament extrusion is handled by an E3D Titan extruder with filament sensor and an E3D V6 hot end including automatic calibration. Interchangeable printing sheets are now standard. As a printer controller, there is a Xiaomi Redmi 9A mobile phone. All the models of this printer came with a Xiaomi Redmi 7A mobile phone. On the printer, we can also find 3 USB ports that can be used to extend the capabilities of the 3D printer. As a nice bonus, there is LED lighting of the build area, Wi-Fi connectivity, remote management, and a webcam with the ability to record time-lapse videos. For the ability to print flexible materials, a FlexPrint extension can be purchased to bring the extruder closer to the hot end. We will talk about that in another part of this video. The mobile app is very clearly designed and contains everything you need to easily control the printer. Of course, there is no absence of functions such as setting temperatures or selecting a file to print. In addition, you can set, for example, the print speed or Wi-Fi connection parameters. Before the first print, the height of the first layer had to be calibrated. For this, I needed a filament that can be loaded into the printer by pressing a button in the application. After loading the filament and preparing the build surface, I just had to start printing the file prepared in the printer. Calibrating the height of the first layer using a mobile phone was very easy, but the mechanical control is more convenient. Then I printed 4 models that I found ready in the printer. The first model was a boat called Banshee. At first glance, you can see a very high quality print. On the body, you can see the line where the deck starts, but it is not unexpected. Under certain light, a strange pattern can be seen, which is caused by the stepper motor drivers. This is a pattern you will find on every print. The company knows about it, and I'm told they are trying to remove it. You can barely feel this pattern to the touch, and you won't even notice it in normal daylight. When you look at the top layers, you will have a very hard time finding anything to complain about. But you can't say that about the cabin. Here you can see a very poorly placed seam. All in all, the print doesn't look bad. The second model was the air spinner. Here you can see that the first layer still needed a little tweaking. But this was not a problem of the printer, but of the operator. I looked at the print and wondered what to say about it. The top layers look nice and are almost smooth to the touch. You can move the print freely, and in fact, the whole print is really good. Apart from the very visible seam and a little fluctuation of the filament flow, there is again nothing to complain about. The third model was Astronaut Filament. You will notice the previously mentioned pattern and more visible seam. In addition, a slight fluctuation of the filament flow can be seen. Other than that, there is nothing to complain about here. Maybe a strange filament line between the astronaut's legs. All in all, this print looks very good. For a printer without a direct extruder, this is actually a very good result. The fourth and last prepared model tested was this carabine. The print looks good again. The first layer was a little higher than it should have been, which unfortunately was due to the automatic calibration of the printer. Apart from the things that are also present in the previous prints, there is nothing to complain about here. Compared to the previous prints, the same print quality is still evident. Unfortunately, this also includes the pattern. Although my filament supply is not the smallest, Filamentum brand filaments were missing. So I contacted Filamentum, who agreed to provide a little support in the form of a few filaments, for which I thank them very much. The more observant of you will notice that some of the boxes are still packed. This is because these are the types of filaments you won't see in today's video. If you are wondering what I'm going to do with these filaments, I recommend subscribing so you don't miss any of the next videos. With 2 new filaments, I decided to print again the Astronaut filament and the boat Banshee. As you can see, the prints are almost identical to the previous ones. Due to the made surface, the fluctuation of the filament flow is a little more visible, but we will look at the origin of this problem later. Now let's check out the remote management of the printer. All we need to do is to connect the printer to the internet via Wi-Fi or the supplied USB network card. In case of Wi-Fi connection, we needed to set the connection parameters using the mobile application. After restarting the printer, the mobile phone started showing me the IP address at which this printer was available. After opening the web browser, the Duet web control interface customized for this printer was displayed. In this interface, I was able to perform more actions with the 3D printer than what I was possible through the mobile app. In addition to basic information about the printer, network connection, tool temperatures, and accessories being used. There is also the ability to use the camera to check the status of the build area, just like in the mobile application. Below is the ability to pause the print, control the fan and print speed, control the filament flow and change the distance of the nozzle from the build surface. At the end is information about the current print. There is also a possibility to start a time-lapse recording of the print progress. You will also find a separate section about this in this video. Of course, there is also a possibility to browse and manage files available for printing, including uploading them to the printer using this interface. These files can be stored on an internal memory card, USB storage, or Google Drive. The Palette 2 tab displays information while printing with Palette 2 connected. In the settings, you can change the printer's name and secure access to the web interface. This printer has LED lights that can be controlled through the mobile and web interface. In the web interface, you can also change the intensity of the lights and set a countdown to automatically turn off the lights. There are also printer parameters and the ability to update the printer firmware. This can be done via an internet connection or by uploading the appropriate firmware file. There is an option to set the Wi-Fi connection and access point parameters. The printer can be set up as a Wi-Fi access point, allowing any device to connect to the Wi-Fi network provided by the printer. In the Accessories tab, you can set up different types of print pads and print heads. This allows you to have different print heads with different nozzle diameters or different types of print pads, for example. For each combination, the printer will remember the first layer setting. To add components, you need to get the configuration file from support and upload it to the printer. The next tab contains links to the slicer profiles, and the last tab contains the printer statistics. I really like the button to upload a file with immediate start of printing and the emergency stop button. Let's now take a look at the printing accuracy of this printer. First, I tried this multi-tester, of which I was most interested in the tolerance test. You may remember this test from the Ready Rebel 1 3D printer video. In this video, the Ready Rebel 1 achieved a tolerance of 0.2 mm without any configuration adjustments. This print was generated with the Prusa slicer using a profile created directly by Trilab. At first glance, the print doesn't look bad, but you can see something is wrong on the top layer. Although looking at the bottom of the print, we can see that there is space around these cylinders. Looking from top, you can see that these cylinders are fused together with the rest of the print. Which means, unfortunately for us, that this printer has a tolerance of around 0.3 mm. This is easily beaten by any 3D printer. So I tried to repeat the print, but adjusted the print parameters slightly. I tried a few different changes, and my best result was 0.25 mm, which is still a very poor result for a printer in this price range. As another test, I tried printing an enlarged calibration cube in a Lego version. On the wall print, we can notice a very familiar pattern. In some places, we can even see a more pronounced hint of fluctuation in the filament flow. The lighting in my studio is adjusted to make these imperfections in the print more visible than they are in daylight, which is not my attempt to defend the flaws in the print. Rather, I'm just pointing out the fact that in daylight you can barely see these errors. Using a caliper, I checked the dimensions of the print. I measured 39.94mm in the x-axis and 39.93mm in the y-axis. Both are slightly off by 0.05 of a millimeter, but in general, these results are very good. We will stay with the tolerances for a while. I downloaded a model of a bolt and a nut from printables.com. It provides a nice demonstration of the importance of tolerances in 3D printing. You need to use a printer with very good tolerances to get the nut to screw on. I printed this model on a Trilab Deltic 2, Ready Rebel 1 and a Prusa Mini 3D printers. You already know the price of this industrial 3D printer. The Ready Rebel 1, like the Deltic 2, is an industrial 3D printer and its price at the time of the recording was around $2,600. The Prusa Mini, on the other hand, is from the category of 3D printers for beginners and DIYers. Its price at the time of filming was around $450. For all these printers, I used their default profiles with a layer height of 0.15mm for the Filamentum PETG material. The only change I made to these profiles was to align the transition to the new layer on the back of the model. Here are all three finished models together. See if you can guess which print was printed on which printer. On the first print, you will notice some sort of limitation on the movement of the nut over the screw. The second print does not have this problem and the movement is much smoother. The third print has no restriction of movement to speak of. The movement is perfectly free. So, do you know which print is from which printer? If you guessed, the first print is from the Trilab Deltic 2, the second print is from the Prusa Mini, and the last print is from the Ready Rebel 1, unfortunately, you are right. The relatively inexpensive hobby 3D printer surprised with both very decent print quality and greater print accuracy than the industrial machine that is the Trilab Deltic 2. The winner of the tolerance test is the industrial 3D printer Ready Rebel 1. The print quality is very similar to the Deltic 2. However, from my own experience, I can say that for most models the Rebel is even better with print quality, and this is mainly due to the direct extruder. While the Deltic 2 prints really well, it loses in the tolerance test. I know I could have adjusted the X and Y axis compensation in the slicer and saved the whole situation. But then, what kind of test would that have been? Normally, I wouldn't experience it much and probably ignore it. But the price of this 3D printer indicates high and long-lasting print quality. The print quality was very good on all three printers I had the opportunity to test. However, if you buy this printer to print models that need to be assembled from multiple parts, for example, I don't want to deal with the parts not fitting together. I want to print the model, put it together, and not have to deal with the hassles that I would expect from a lower priced printer. What is the point of having the same print quality if I have to take into account the potential problems of assembling the finished print before each print? The website says the printer can print technical materials such as ABS, ASA, nylon and nylon with carbon fiber. It's clear to me that the printer can print nylon and nylon with carbon fiber. However, I also know that the lack of the heated chamber means that it's not gonna be anything to write home about. But I was wondering how the printer would handle common materials like ABS and ASA. Before the test, I treated the build surface with Dimafix to increase adhesion. I first tried printing green ABS from Filamentum. In the parameters, I set the brim and draft shield around the print to protect the print from ambient temperatures. The print stays in place and doesn't move, so it should be very easy for it to stay in a near constant temperature, even when the temperature around the print changes. You can see the print attempted to detach from the print pad, but in the end, the print turned out surprisingly well. Except for the top layer. It's over-extruded for some unknown reason. I tried printing again, but this time with ASA material from Filamentum. All the settings remained identical to the previous profile, only the material type was changed. Here it wasn't so great anymore. Not only was the first layer printed a little higher than it should have been, but you can see the corners attempting to detach from the print pad. The top layer turned out even worse than with the previous print. However, it confirmed my expectation that this printer can print these materials, but a heated chamber would definitely help for better results. Such a heated chamber has, for example, the Trilab Aztec 3D printer. More about that one another time. I started thinking about who this printer might be suitable for. Sculptures and architectures don't need perfectly accurate printing. They are more concerned with appearance, speed and print quality. As a first print, I tried printing a very ordinary vase from a very interesting purple PLA filament, again from Filamentum. The result turned out beautifully. If it wasn't for the already well-known pattern and the slightly increasing visibility of the fluctuation in the material flow, the print would have been perfect. For the second print, I chose a lion sculpture created using 3D scanning. 3D scanning is a very special type of model creation where you never know how the 3D printer will handle it in the end. This is because it is not a model created out of a standard geometry shapes. After the printing was finished, I got a slightly unpleasant surprise. You can see a lot of mismatched layers in the model. Here you can see that I forgot to add supports in some places, so a couple of times it started printing in the air. But I would say that's one of the minor problems with this print. For example, look at the paws and how they look after the supports were removed. The print itself looks nice, but there are a lot of places that are just wrong. So let's take a look at a model that is made up of geometric shapes and is made for architects. After scaling the model up to 250%, I also had a chance to test the printer's behavior during almost 2 days of printing. The printer, in my opinion, actually handled the printing quite well. This model looks simple, but appearances are deceiving. The huge number of holes that represent windows were a living hell for the printer. There were a lot of direction changes needed that would have been worse on a printer where the print is moving. Probably the last nitpick is the print cooling. It could have been stronger, as can be seen in the windows on the lower floors of this building. Along with the printer, I received the FlexPrint 2 extension. The FlexPrint 2 is actually a direct extruder controlled by a steel wire and a stepper motor. By placing the motor outside of the printer, the print head stays light and there is no need for any print speed limitation. Before you start shouting that this is the Zesty Nimble, let me stop you for a second. The FlexPrint 2 is heavily inspired by the Zesty Nimble, a product that Trilab even used previously and still has a section in the manual about. However, a situation occurred that made it necessary to go independent and create their own product. To install this extension, all you had to do was plug the extruder motor into the bracket on the back of the printer and plug the connector into the hub. Then you put the PTFE tube that was included in the package into it and the other end of this extension snapped into the holder. By doing this, the FlexPrint 2 was installed in a state where it could always be when not in use. In order to start using it, I had to uninstall the existing Titan extruder. First, however, I had to remove the PTFE tube from the print head. To do this, all I had to do was remove the connector lock, apply pressure to the connector and pull the tube out. And the same had to be done on the Titan extruder side. I then removed the tube from the printer and store it in the vertical profile as recommended in the manual. I put the connector lock back in place and moved on to installing the extruder. To install it, I had to use that small PTFE tube which I had previously put in the extruder motor holder. I received 2 of these tubes along with the printer in case I accidentally lost one. I had to insert the tube all the way into the hot end with the side that looks like a funnel sticking out. Then all I had to do was put the lock back on, unscrew these 2 screws and put them away in the extruder motor mount. The last step was to put the extruder on the hot end and screw it on. Now that the installation was complete, all I had to do was insert the filament into the printer and let the printer load the filament itself. Although this extruder is mainly for printing flexible materials, I found a ready-made file in the printer for printing astronaut filament. Here is a comparison with the astronaut that was printed using the Titan extruder. Both print looks pretty damn good. In the case of the flex print, I found that the transition to the new layer is less visible. On the other hand, the fluctuation in the filament flow is more noticeable. Both prints look very similar. You definitely don't buy this extruder to print PLA. You buy this extruder to print flexible materials. For the test I used FlexFill TPU 98A Sky Blue from Filamentum and printed on a layer of a 3D lac. I was surprised at how well this print turned out. Beautifully smooth surface, minimal fluctuation in filament flow, no mismatched layers. In fact, the print turned out pretty damn good. Even excellent for a Delta printer and a flexible material. Next, I tried printing FlexFill TPE 96A Light Gray from Filamentum. Filamentum recommends printing this material on a surface treated with Magigoo Pro PP. Unfortunately, I did not own this product. So I tried 3D lac, Corres glue stick, Dimafix, and lastly, ordinary office adhesive tape. TPE slightly shrinks when it cools down, and if the adhesion to the build surface is not perfect, the print has no chance to stick. The only thing that helped the model to print successfully was the adhesive tape. Unfortunately, the adhesive tape had no chance to stick to the build surface, and even worse, it remained very aggressively attached to the print. Ignoring the point where the adhesive tape came off the build surface, the print is actually almost perfect. But now back to the TPU, which could be printed without any problems. I tried to print this calibration aux with it. As expected, we can see stringing on the print, lack of cooling in some places, and fluctuation of the filament flow. Since we are printing elastic material where retractions is almost a curse word, and it is not recommended to cool it much, this print is actually as expected. After printing the calibration aux, I decided to go back to the original plan. This was to print the lens rings. I printed a total of 7 of these from TPU, plus one failed one where the nozzle got clogged during printing. Unfortunately, I don't know the reason for the clogging. All these rings turned out perfectly. When I also take into account the very good print of the calibration aux, the very nice print of the TPE rings, and the damn good print of the PLA rings, FlexPrint looks like something that everyone must purchase with this printer. Let's go back to the Titan extruder. Now it's time to test the filament sensor, filament change, and print recovery after a power outage. I have prepared a model to which I have added filament change. When it came to the filament change, the printer paused the print. The print head moved aside, the filament partially ejected from the print head, and that was it. The phone didn't show a single piece of information, and nothing actually happened at all. So I tried opening the tune section of the menu and clicked on filament change. After changing the filament, printing continued. After a few minutes, I cut the filament to test the filament sensor. Here, the process was basically as expected. The printer stopped printing, ejected the filament, and asked for a change. After changing the filament and confirming the change, printing resumed with the new filament. Let's take a look at the result. You can barely see the beginning of the print at the filament change point. At the point where the filament sensor test took place, you can see an insufficient amount of filament at the beginning of the print. I wanted to test print recovery after power outages. Unfortunately, the printer doesn't have this functionality. I tried to repeat the test, but the result was basically the same. Judge for yourself. One of the interesting features of this printer is remote management. You already covered a lot of information about it at the beginning of the video. But this remote management is more powerful than you might imagine. Because when you purchase this printer, you agree that your printer will connect to TriLab servers. To a mere mortal, that may sound unacceptable. For a corporate client, on the other hand, this is a huge benefit. One plus is that the printer can check itself for a new version of firmware and offer you an update. The other plus is that support can connect directly to the printer, retrieve logs from it, look through the webcam, and even control the printer. For example, if you have a printer in your company and need to fix a problem on it, just contact support. Support will connect to your printer and help you solve your troubles remotely. For you, this means a huge saving in time and therefore money. You can enable the creation of time-lapse printing videos in the web interface. The videos are only 640 to 480 resolution, and honestly, they are not gonna make you sit on a res. The camera is located at the top of the printer, so most of the time you can't actually see what you are printing. For larger prints, you can see what you are printing, but you can't see what your print actually looks like. While this camera won't give you gorgeous time-lapse videos, it will really help a lot with checking that the printer is printing okay. It will also allow support to see if the printer is responding to the commands they send it. Do you remember when I talked about the 3 USB ports on this printer? In addition to the network card and USB drive, you can plug in things like a webcam or other recording device. Using a USB webcam and placing it further away from the printer will give you a better view of your printing progress. Using a USB capture device and a camera can give you something like a higher level webcam. As well as giving you a beautiful clear view of your print progress, it also allows you to create a very nice time-lapse videos and even in HD resolution. Let's take a look at the noise level of the printer. I did a test in a room of 12 square meters prefabricated apartment. The printer was on a walnut wiener table a few centimeters from the wall. And I use a Voltcraft SL100 noise meter set to measure the sound at a dBA level. The measurement was taken 1 meter away from the printer while printing a sample file from a memory card. The printer noise level was slightly above 53 decibels under these real-life conditions. However, the airflow of the printer fans made the most noise. Here you can hear the printer without the fans, which only turn on when the nozzle heats up above 50 degrees Celsius. Given the price of this device, you can certainly understand that I couldn't just take off the top cover and see that this printer is powered by a Duet to Ethernet with a Raspberry Pi 3B Plus and an external Bluetooth module. I simply couldn't do something like that. Now it's time to look at this printer from 3 different perspectives. Actually, no. With this printer, it makes no sense to look at it from the perspective of a mere mortal or a printer builder. This printer is not for them. For them, there are plenty of other, cheaper, and even better quality 3D printers. This printer is designed for business, in which 3D printer is mainly used to create prototypes before final production or various tools. For a business where the 3D printer is a tool you use and you want it to work as long as possible without the need for technician intervention. Not a toy that you are constantly tweaking and adjusting. For a business where every minute counts and waiting days or hours for a technician is not an option. Before I tell you what I had problems with and what my opinion of this printer is, let's recap what's interesting about this printer. This printer provides one of the best remote management I have seen on a 3D printer so far. During a call with support, watching the person on your phone remotely check your printer, run printer diagnostics, or even update your printer's firmware is something incredible. Add to that the mobile app, the web interface including a webcam, and the ability to capture time-lapse videos. I'm speechless. Exchangeable printing sheets don't surprise anyone anymore, but printing elastic materials on a Delta printer still does. High-quality components from E3D, linear rails from THK, an emergency stop button, and the combination of the Duet 2 with the Raspberry Pi 3B Plus make this printer a true industrial machine. But there are two sides to every coin. So let's take a look at the other side of this coin. Most of the time, everything worked perfectly. Unfortunately, very often the printer would connect to the internet, but I couldn't connect to the printer. Even though the router could see it and I was on the same network, I couldn't connect to the printer. While this is annoying, a so-called hard reboot of the printer usually helped. But what I found unacceptable is that a mobile phone, which is here as the main control, cannot connect to the printer. The phone connects via Bluetooth, and if this connection is not working and the printer is not connected to the internet, the printer cannot be controlled. In the case where the printer does not print, this is not such a problem. Just restart the printer. But if the printer is printing, a reboot is the last thing you want to do. If the printer is connected to the internet, there is an option to control the printer through the web interface. Well, as long as you can connect to the printer. Since this is a software bug, the company will certainly have no problem figuring out where the error happened and resolving everything by simply updating the printer firmware and mobile app. If you disconnect the printer from the power source and forget to turn off the phone, you may find yourself unable to start printing until the phone is charged enough to be used as the printer control. Remember how I pointed out several times in this video the fluctuation in filament flow and the appearance of the transition to a new layer? No? So next time don't skip the video and watch the whole story. I spent a while looking for what might be at fault. The first problem was in the PTFE tube. Its length and 2 mm inner diameter cause the filament to twist in it, making the filament flow inaccurate. But there is another problem. During printing, during retractions, I noticed the PTFE tube connector lock on the extruder side moving. I'm not sure what effect this had on the print quality, but it certainly isn't good. I would recommend the company think about a PTFE tube with a smaller inner diameter and a better PTFE connector lock. This actually brings us to the end of the video. The printer itself is a very well built machine. But if you ask me if I would recommend this printer, my answer would be no in most cases. This is because this printer is not for most of my followers and friends. This printer is an industrial machine and the requirements are completely different in an industrial environment than in a home environment. I have talked about this printer with friends who are working in the industrial environment. From my point of view, the print quality was just very good. From their point of view, it was better than what they are used to. From my point of view, the print tolerance was not good enough. From their point of view, the print tolerance was sufficient for most of the prints that they use 3D printers for. So if you come to me as a company that this printer is made for, my answer is not going to be no. Actually, it won't even be yes. Who am I to tell you what to buy for your company?